We are going to do 11, 12, and 13 together. So what I'm going to do here is I'm going to graph this on my calculator because it says we have one. We can use it. So I'm going to type in these equations up here, and you got to make sure your mode is in radians. When you are in radians, is right there. You got to make sure that radians is highlighted when you're graphing a trig function. So I'm going to hit y equals, and I'm going to put in 2 sine x. Hope you remember that 2 makes the amplitude go up and down from -2 to 2. And then the 2 inside makes the period half for cosine. So I'm going to type in cosine of 2x. Okay, and then I'm going to look at the picture because I want it to resemble the picture. So this says we want to graph it from -pi/6 to pi. So I'm going to go from negative pi divided by 6. Oops, sorry. I got to go back. I forgot to go to window, so I got to delete all this. Negative pi divided by 6 to pi. If you want the TIG marks to be right, you see the TIG marks are pi/6. So this next thing down the X scale, that's your tick mark. So if you want to make your tick marks line up, which I'm going to go ahead and do, you don't have to, but I'm going to put these as pi/6 because that's what it says the tick marks are. And then I'm going to go from -1.25 to 2.25 for Y because that's what he did on his picture. And if you look, he's got a 1 up there on the first tick mark above X, so that means that's what he wants. So I'm going to hit graph, and here comes my sine graph right here. Did I hit 2.25? I did? All right, let me go back. Yep, I did. Y min was, oops. I did the Y min right, just not the Y max. All right, we're going to come down here and make that 1. I want it to look like his graph. So here comes sine. And then here comes cosine. So I'm going to go ahead and sketch those in there. So I know that sine goes through the origin, so I'm going to go ahead and put a dot on the origin. And I know its max is at pi/2, which is right here at 3 pi/6. So my max is 2, and then it was back to a 0 out here at pi. So this graph is going like this. So there's the sine curve, and the cosine curve, if you remember, starts at a 1. 0, 1 is where it starts. Let me show you the picture again real quick so you can see it's going through 0, 1 right here. 0, 1, and then it's going to be a minimum at pi/2 because we have actually made this period twice, two periods. What that 2 right there does is put 2 periods where normally 1 is. Okay, so it's here, and then we're going to come down, and it's going to cross in here, and then it's at a -1 here, back at a 0 here, and it's kind of going along this deal right here. So I hope you see the part we have intersecting. We're looking at this part right here. This is the intersecting area on that picture that we want. So I'm going to take my calculator, and I need to find these points of intersection. Okay? Now, we'll just find it. If you remember, we could be able to find them without the calculator if you know your unit circle. But I'm just going to use my, oops, let me get the graph up here. We're going to find the intersection on the left, and I'm going to write them on my sheet. And then we're going to find the intersection on the right, and I'm going to write that. So I'm going to hit second trace, which is calculate, and number 5 is intersect. And then I want to get over here, get my cursor over here by the intersection, and we're going to hit enter, and that's going to jump it to the red one. So the sine one enter, the red one, are those the 2 you want? Yes, you hit enter, and then enter a 3rd time, and that little x value there that says 0.37473,443, that's my intersection. I'm going to save that on my calculator. So I'm going to hit second quit, and then I'm going to hit the x. I'm going to hit x by the alpha, and then I'm going to come down here to left of 1 and hit store, and I'm going to hit alpha A, and I'm going to put that into A. So there's that x-intercept. Now you should probably write it on your paper. I'm going to write it in a minute. And now I'm going to find the second intersection. So I'm going to hit second calc 5. Now I got an arrow way over there the other side by the other intersection. I'm going to hit enter, enter, enter. And that one is 2.766, whatever that is. I'm going to hit second quit. And I'm going to say, hey, we're going to take that X and we're going to store that in alpha B, which is alpha apps. And there's that one. Now I'm going to write on here. I'm going to write on here. Over here, I'm going to put this thing right here. And I'm going to tell them that that intersection was 0.374 ... Because I am not rounding that. I just saved it in there. And this intersection right here is 2.766 ... And I don't really care about the y's right now. I probably would write them in on the AP test just so you found them on your calculator. And then I'm going to come up here and I'm going to say A is going to equal this and B is going to equal that. And then I don't have to write those decimals in anymore because I'm telling you what they are. So if you remember, when we want the area, we're going to find the area of the top minus the bottom. So I'm going to do the integral from A to B. And then the top one's the blue one. So that's going to be 2 sine x minus cosine 2x dx. That's what I'm going to get my answer to be. Now, I don't know how much you remember, but when I type this in my calculator, and again, if you want to put down here 0.374, but put your dots, because if you round before your last step, your answer will be taken off. 2.766 ... You can do that as well. But when you type this into your calculator, here's what I'm going to do. I'm going to hit Math 9. And if you remember, that's A, so because I stored it in, I'm going to hit alpha A. I'm going to arrow up. I'm going to hit alpha B. And then over here, I'm not going to type that whole thing in because y1 is where I put 2 sine, right? You can type 2 sine minus cosine 2x, but when you do your test, you want to be able to do this because it will be faster. And then minus, and I'm going to put in y2 because that's where I put the cosine one. Ah, I hit the wrong button, stinking thing, bars, y bars. And it's with respect to x. I'm going to hit enter, and there's my answer. So I'm going to say this is approximately 4.404 would be what we're looking for. Question on that. Okay. You must, if you just wrote this answer down, you wouldn't get any points. You must show them what you're typing into your calculator. If you don't show it, you lose all your points. All right, we're going to go on to 12 now. All right, so this says we want to find the area between this cubic and the tangent line. So what are we going to have to find? We're going to find the tangent line, aren't we? Right? So I'm going to do the derivative of this function, and I'm going to get y prime equals 3x squared. So I'm going to do y prime at 1 because that's that x value right there I want, and this is going to be 3. Am I going too fast? Okay, so my line, my tangent line is y minus 1 is going to equal 3 times x minus 1. And then I'm going to go ahead and solve this for y. So I'm going to get 3x minus 2, because that would be minus 3 and add the 1 over. Is that okay to everybody? So I got these two graphs. Now this one doesn't say calculator, so I'm not supposed to use a calculator. Now this is called the point of tangency. What do you know about the point of tangency? Does anybody remember? Evidently not. The point of tangency is not only on your line, it is also on your function. So what that tells me is this point, let's see, the x-axis is here. So here's the origin. This point, 1, 1, is on both graphs. That is on my tangent line, and that is also on my cubic. So there's a point of there's a common intersecting point right there. So I'm going to graph this line, y equals 3x minus 2 in red. So let's see. The y-intercept is 2. If you look, these are going by 1s up and down, right? So I'm going to go down 1, 2. Let's go down, then I'm going to go down 3, 1, 2, 3, and over 1. But if you look going sideways, you see the sideways are only halves. So you got to go 2 places over. I'm going to go down one more time. 1, 2, 3, 1, 2, dot. So here's my tangent line right here. That's my tangent line. I'm going to graph the other. Now, you can't use colored pencils on the AP test. You have to use pencil. I don't know why, but they don't let you. So I'm going to find the place where this cubic intersects this line. Okay, so we're going to go back to some pre-calc and algebra 2 stuff. Wherever these two things are equal, that's where they intersect. So I hope you remember that you're supposed to get any polynomial equal to 0 in order to find the intersections. Now, do I already know one intersection x value? I know 1 works, right? So we're going to do synthetic division. I'm going to put 1 here. And then I'm going to do synthetic division where I write down the coefficients of the equation. And I bring that first number straight down. I take 1 times 1, put it under here, add these together. 1 times 1, put it under here, add these together. 1 times negative 2 is negative 2. And as long as I get a 0 right there, that tells me that is a 0, which I already knew from up here. So this point is on both the cubic and on this. Now I can find the other intersection by changing this back to x squared plus x minus 2 equals 0. And now this will factor to x plus 2 and x minus 1. So my other zeros are x equals 1 and x equals negative 2. Well, I've already got the x equals 1. That's called a double root. If you remember, if the same root works once, they call it, or more than once, it works twice, they call this a double root. So that means negative 2 is also an intersection. So if I go over here to 1, 2, there's another intersection right there. Now I know that the cubic goes through the origin. And I know that this is a point of intersection, or tangent line, so that it goes up like that, and it comes through here, and it hits that, and then it goes down here through this thing, and then it comes over, and it goes down like this for a cubic, if you remember all that stuff, and it keeps going. But I don't really care. The part I need is the intersection. So I need this part. This is the area I'm looking for right there. Y'all see where that comes from? If you guys remember P over Q's, that would have been another way to solve this equation to get my intersections. And if you want me to do that for you later, I will, but the film's getting too long now and we got a quiz to take, so I can show you P over Q's again. So what's the part on top? The blue line, which is my cubic, right? And what's my left intersecting point? Well, this one is negative 2, negative 8. And this one was 1, 1. So what's on top the whole way, the cubic or the line? Cubic. So that means I'm doing x dx because we got a top minus a bottom. So my left intersecting point is negative 2 for x. My right one is 1 for x. The cubic is on top, so it's x cubed minus, and then the line's on bottom, 3x minus 2. So there's my equation. We all okay to where that came from? You need to finish it. I'm going to finish it because some of you are looking at me weird. So I got x to the 4th over 4 minus, oh, I'm going to distribute this. That'd be a minus and this would be a plus. So I got minus 3x squared over 2 plus 2x. And we're going from lower bound of negative 2 to an upper bound of, I wrote 3, but it's 1. Negative 2 to 1. So you plug your upper bound in first. So 1 to the 4th is 1 over 4 minus 1 squared is 1, and 3 times 1 is 3, so that's minus 3 halves. And I should have an x right there, because that was the integral of 2 is 2x, so somebody should have yelled at me. And I plug a 1 in there, so it's going to be a plus 2, and then minus. Now I got to plug negative 2 into all these places, so that's negative 2 to the 4th over 4, oops, minus 3 times negative 2 squared over 2 plus 2 times negative 2. Now that right there can be your answer in this class. You have to do no more. That's your area right there. But I'm going to simplify it anyway. So let's see. We got 2 and 1/4 minus 1 1/2 right here. And then, let's see, we got a minus, and then in here I got 16 over 4 is 4, and then that's 4 times 3 is 12. 12 divided by 2 is minus 6, and that's minus 4. So let's see, these 4's cancel, right? So minus a negative 6 means plus 6. Okay. So let's see, this is going to be 1 5/4 if I borrow 1 from that, right? Minus 1 2/4. Is that right? And then over here I got plus 6, I believe, right? In common denominators, I think I borrowed that, right? So 1 minus 1, 0. 5/4 minus 2/4 is 3/4. So this is 6 3/4 would be your answer. Question 13. 13 says, find the value of B if the vertical line x equals B divides a region between this line, this axis, and this axis into 2 equal regions. So let's draw the graph. So there's my y-axis, there's my x-axis. So I know these are 2 things that are part of the boundary. Now if I plug in 0 here, I get out my y-intercept is up here, 16. And if I plug in 0 for y, and I add 2x over and divide by 2, my x-intercept's down here at 8. So this line, pretend that's a straight line, that line tells me that the part that is between the x and y axis in that line, this is my area. Everybody okay there? Now, somewhere they said, down here at the bottom, there's some b value. Well, there's 0, there's 8, so somewhere in here there's a b. Let's put a different color. Let's call this b right here. So if I draw that vertical line x equals b up to here, we're going to say that that line now keeps going up and down, but we don't care anywhere else. That line's doing what to the yellow part? Cutting it in half. Okay? Now what we do right now, there's a million things we can do. I can get the area of the yellow, because isn't that just a triangle? So isn't the area of the yellow going to be 1/2, the base is 8, the height is 16. Let's see if I reduce those, I believe that's 64. So the area of the whole place is 64. So what's each side of the B? So this side area is 32 and this area is 32. We all okay there? Now what I do right now, there's about 4 or 5 different ways I can set up my equation to solve it. I'm going to do what I think is easiest. I'm going to say the integral from 0 to B, and what's on top from 0 to B? What's the top function? It's the red, right? Minus the x equals 0 down here, or y equals 0, I mean. So it's going to be the 16 minus 2x minus 0, because this line's 0. Dx is going to equal how much? That should equal 32. Now I'm going to do integral. So I get 16x minus 2x squared over 2. I hope we know that reduces. And over here, my lower bound's 0, my upper bound's b, and that's 32. Am I going too fast? So now I'm going to plug in my upper bound. So I'm going to get 16b minus b squared. And then you plug in 0. So that's going to be minus 0 is equal to 32. So now I have a quadratic, right? You all see the quadratic? I got to get a quadratic equal to a 0. Actually, there's other ways to do it. Let me do it another way. So I'm going to add my b squared over here to this side. I'm going to subtract 16b over, and I've already got plus 32 over here. And I would try to factor because that's the fastest, but this doesn't factor. Sorry. So now you can either use quadratic formula. Do you all know that? I'm going to show you what I think is faster. I'm going to complete the square to solve it. You guys did that too. My favorite is completing the square. So I need to get negative 32 to this side, and over here I got b squared minus 16b. And then I got to complete the square of this. And the reason I'm doing this, is I want to, I think this is faster. So the way you complete the square is you take half of the linear, so half of 16 is 8, and you square 8, which is 64. So I add 64 here, add 64 over there. I get 32 equals, and then I can factor this perfect trinomial to b minus 8. You square root b, you take the sign in the middle, and you square root 64. And then you square root both sides, you get plus or minus 32. It's b minus 8, and then you add the 8 over, so b is equal to 8 plus or minus radical 32. Do both those answers work? Do they both work? No, why? Yeah, if you're already at 8, wouldn't the square root of 32 be like 5.6-ish? Am I a genius to guess 5.6? No. What's the square root of 25? 5. What's the square root of 36? So isn't this 32 a little closer to 36 than it is to 25? That's about 5.6, 5.7. I'm not a genius, I just know my squares. So if I'm already at 8 and I add radical 32, what is there about that b up here? And it beyond the triangle? You see how that won't work? So we got to get rid of this one. So this right here is your answer. Now, if you want to rewrite that as 8 minus, and you want to take the square root of 16 out of that and leave 1, 2 in there, if you want to write it like that, that's fine. But again, once we plugged in, I guess this one you did have to get rid of the plus sign. Okay? Question. Do you guys think that's faster than quadratic formula? Because I sure do. I like that method better. I wish we taught it only, but we don't. All right, that's all that homework. I'm going to shut off the video. Does anybody have any other questions before